So I interrupt this regularly scheduled lecture for conversation about hurricanes today. All right, as you guys probably know, Hurricane Adelia came flying through over the last couple days, and I really ought to just plan on this being a permanent lecture for fall semester, because every year, you know, it's been happening literally on or around the first day of class, sometimes the weekend before, but right then and there. Sometimes we've had a couple more afterwards, at least one more afterwards. Sometimes we don't have any more. And we're not going to get into the politics of this and marker date and whatnot from a few years back, and not going to talk too much, even though, again, realm of earth science is why we're talking about this, about, we don't call it global warming anymore, climate change, okay? This is really just a info about the how, the why, the winds of hurricanes, okay? So, some of this you might know, some of this will be new, and then a little bit of it will be the in-between. Any of you ever been in a hurricane? Yeah? When? Where?
2018, I forget what it was, but it was down in North Carolina.
You guys on vacation, or did you live there?
I lived there. I was stationed down there for 4 years.
You guys right on the coast or inland a little bit, or?
We were right on the coast of Jackson, North Carolina.
Okay. How did that affect the base? Were they should be set up to sort of be used to that, right?
They shut it down for like 2 weeks.
They sent you guys home?
They sent us home.
Holy cow.
Like, everyone get out of here.
It must have been kind of a bad one coming then.
Yeah, it was pretty bad. A lot of North Carolina got flooded out. A lot of homes got lost. Everyone.
Okay. Oh, I think we went to visit up Kitty Hawk Way the year after that. They might have been talking about it, how things have changed. And we're like, oh, this is our first time here. Sorry. We didn't know the difference, but I think I remember. I can't put a name on it, but
we had just gotten back from Trident Junction over in Norway at that time.
Oh wow!
It was around like Thanksgiving.
Okay. Yeah, they could go into November, which is what we're going to talk about today. And you aren't immune from them, for lack of a better word, up here in New York State either, which is another reason I talk about it. Yeah, we don't get the pounding winds and buildings getting torn down and everything, but there are many, many times something called the rain bands, which you guys will learn about in a minute, have definitely made it up here.
Was that the rain that happened yesterday?
No, just I've got some pictures. That's kind of what I was taking the first couple minutes of class there doing. I have been screenshotting for weather nuts like myself. iPhones have been a wonderful thing with radar and the apps and all that for decade now plus. So I like to take radar shots of the hurricane, and I put those together as a little thing so you could see exactly where it was moving. Now this one ended up nowhere near here. It's back out to sea at this point. But yeah, definitely in years past, and you'll see some. I've got some pictures to show you. But so it's not completely removed from you. So you didn't actually, if they evacuated you guys, you didn't actually experience it then. You just got evacuated because of it, right?
Yeah, I mean, we got back and everything.
Oh, you had to deal with the cleanup.
Yeah.
First big one for me, and I wasn't there, but good Lord, the whole world was hearing about it, was Katrina. And if you guys don't remember, Katrina's the one that flooded out New Orleans. New Orleans is bowl-shaped, and when you fill a bowl up with water, it tends to stay there. It wasn't good. It wasn't good. And people were like taking weeks off of classes and going down and helping out, or taking work off and going down and helping out. It was crazy. It was probably 2001, 99, and somewhere thereabouts. I'm sure it's in here. But. So, anywho, as I said, we're not going to get too much into the politics of it all, but unfortunately, science, shouldn't be politics, but it happens. That's what all the fuss is about. Doesn't look too horrible, right? That's Isabel. You can't read the print down there, 2003. And what you're supposed to notice in this is not just its beauty, and you're going to hear me say that a lot.
It's huge.
It's huge.
It can see like the circumference of the Earth and everything.
Yeah, I was just going to say there's not a lot of perspective, but you can see some curvature there. There's nothing there for scale, though, short of the edge of the planet. Good point. Thank you. But it is, in this case, it is very big. What I wanted you to notice was the perfect formation. This is why I've got this one up here. You're going to learn about the parts, okay, as we go through this. But I mentioned rain bands a little earlier. These are the rain bands. They swirl around, basically the outside of the hurricane. And then it pulls into this tighter, until you see this more solid point in the middle there. Let me move the mouse around so the folks at home can see too. Right in there, okay, you've got the center part of the storm. Right, it's your eye wall, and then in the very, very center, of course, is the eye. All right. And the eye is known for being calm and so on and so forth. We'll talk about that. But this is a great, as far as anatomy goes, this is a great picture. So beyond this, what is a hurricane? All right. So hurricanes are tropical cyclones. We'll define that word in a minute. With winds that exceed 74 miles per hour. Odd number, I know. A lot of times when the numbers are weird, we kind of write it off. Oh, it must have been converted from metric, or no, it still doesn't even. It's just 74 miles per hour is what they decided. They circulate counterclockwise. And if you've heard things about the opposite in the southern hemisphere, that's actually true for hurricanes. Okay. Let's go back to this guy for a minute. So, which way is counterclockwise? Rotating to the right or rotating to the left? Left, okay. So if you go in, you kind of got to count these because there is one of those silly questions on the test. Which hemisphere is this hurricane located in? Just picture it like a big old roll of toilet paper, paper towel, all right, and see which way it's wound up. And it's not that way because that would unroll it, right? This rain band would start trickling down to the. If I went this way, and for you folks at home, I'm turning my hand to the right. No, it's wrapped this way. Okay, so that is counterclockwise. So this one is in the northern hemisphere. Spoiler alert, I don't have any pictures of hurricanes in the southern hemisphere. I really should, for example's sake. But I'm almost positive they're all northern hemisphere ones. So a cyclone with winds faster than 74 miles per hour, rotating counterclockwise around a low point. I'm not sure why that low point isn't in here. You'll definitely hear it again in a minute. But there's a reason to it. There's science to these. Go figure. So what the heck's a cyclone? Oh, here's where the low comes in. An atmospheric system characterized by rapid inward circulation. And don't worry, these PowerPoints are on, not Blackboard anymore, D2L. Rapid inward circulation of air around a low pressure. Okay? Now, I don't expect you guys to know a whole lot about meteorology. All right? The folks in my earth science class who are going to be watching this video as well don't know a whole lot about meteorology yet. Even in earth science, we don't talk a whole lot about it. But generally speaking in life, things go from high to low. Okay? Think about a balloon. High pressure inside the balloon, you let it go, it goes, zips all over the room because the air is coming out. It's lower pressure out here, so it moves from high to low. All right? That's what's going on here. So you've got this low pressure center and a whole bunch of air whooshing into it. And that whooshing starts it rotating. If we end up talking a little bit about cosmology this semester, which I may or may not do because we're doing hurricanes, there's also precedent for that with stars and galaxies coming together. How a bunch of material coming inward starts things rotating. You guys know it as the merry-go-round effect. All right, not a whole lot of merry-go-rounds left on the planet, but remember, you've seen them in playgrounds and at least on TV. Stranger Things, they had one. But the kids jumping onto the merry-go-round give it a little boost of energy, and that keeps it spinning. All right, and the same thing happens here. in space. There's a physics word for it, but we don't want more vocabulary words, right? Now, we're going to be talking about like we want one of these things to come. I know that's counterintuitive, but again, it's class and we're trying to build one. So we're going to say, we want this, we want that, and if you're in the path of this, of course you don't want that, but we're on the flip side here. All right? So they start as thunderstorms. Bunches and bunches of thunderstorms. And again, that's kind of weird to think about up here because thunderstorms, boy, they come in, boom, bang, bang, loud, scary, and then they're gone. They don't last. Right? But out in the ocean, they can last because they have a constant source of water, of energy. All right? So those thunderstorm cells can keep getting fed, and as such, they can last for some time. And then they merge and form these super thunderstorms. And then we need a handful of factors. It says grows to hurricane strength with cooperation from. There's a handful of factors. You'll see those in a minute. Actually, you're going to see one of them now. The water needs to be 81 degrees Fahrenheit. So 74 miles per hour is wind. We got numbers. I apologize. We hardly ever have numbers. I told you that. And on first lecture, I'm throwing numbers at you. But don't worry, I'm not going to say 81, 82, or 83. Okay, I'm going to say 71, 81, 91. We'll make it more about magnitude than one number. So the water's got to be warm. That's why it takes so long for hurricane season to kick in. That's also why, I said I wouldn't talk about climate change, that's also why they're worrying about the ocean staying warmer longer, because guess what? If it doesn't take as long for hurricane season to kick in, that's going to start earlier and earlier and earlier. And if the waters never get below 81, which is some parts of the world, that's a thing, you see where that's going. And also norther. I know norther isn't a word, but it works really well. You start to see hurricanes hitting Jersey. When the hell has that happened? Okay, Massachusetts, Long Island, all in recent history. Never used to be a problem because the waters weren't quite warm enough. All right, what else do we need? In addition to really warm water, we need high relative humidity. Don't worry about the word relative there. Just worry about high humidity. We know what that is. We've felt that. We're going to get some probably in September again if history is any judge. And don't worry about lower to middle troposphere. Up in the air. All right? We need it to be really humid up high. Why? Because, again, we want to sustain the storm. Remember, we're trying to build a storm here. So you need thunderstorm complexes floating around, coming together, warm water, and high humidity up high. Because that reduces the amount of evaporation. Some of you know this, some of you don't. When it rains or even snows, that's tearing the cloud apart. All right? That's cloud droplets coming down. So it's a eliminating process from the get-go. Again, that's why around here, thunderstorms come in so fast and furious, live fast, die young kind of thing. Okay? There's nothing to keep feeding them usually. And don't worry about latent heat either. This was written for a weather class years ago. Some of these slides, at any rate. But latent heat is the energy thing. It's tied into evaporation, condensation. Remember those words? So when that happens, energy gets transferred. All right, what else don't we want? We don't want strong upper level winds. We don't want wind shear. Wind shear or strong upper level winds, that's a tongue twister, is an eraser, basically. Think about it. You're trying to build this storm up, and if you've got strong winds up there blowing horizontally, they're just going to keep blowing away the top of your storm. We can't have that. So, again, you see why this is, I don't want to say rare, but you see why it doesn't happen every day. You've got to have a lot of things lined up for these to work. Again, don't worry about the latent heat. We want this storm to grow vertically. Sort of related, I almost got some really great cloud pics the other day, but I was doing 70-ish, and it was a really curvy road, so I opted to not die or kill someone else. But you hardly ever see cumulus clouds doing their building thing until they hit Thunderhead. I was heading towards like Little Falls down there on the thruway. Beautiful, beautiful. Watch the clouds, you guys. They're pretty. Earth Science, they get to do a cloud journal. You guys, I can only tell you to watch the clouds. All right, so if all of those things happen, again, what was it? Warm water, high humidity, low wind shear. If all of those things happen, this process can go forward. Again, we start with thunderstorms. Those thunderstorms come together over time into something called a tropical depression. Over time, if those characteristics stay, we get moved up to a tropical storm. And if the tropical storm maintains and continues to build, it turns into a hurricane. Now, used to be, you guys hear about stuff when it turns into a tropical storm. That's when they name them, okay? You ever wondered why the last thing you heard was a B, like Hurricane Bob? Well, no, Tropical Storm Bob, and then you don't hear about anything, and next thing you know, they're on Jake, okay? What happened to C-I? Well, they blew off into oblivion. They went somewhere that the media doesn't care about, whatever. But they do go in alphabetical order, and they name them at tropical storm. However, lately, it appears, and I don't know if this is an official policy change or not, they've been naming depressions or talking about depressions. And I only know this because one year, semi-recently, they talked about, and again, they named it, and they're like, Carl Depression Carl likely to turn into storm. And it made it sort of sound like he was a evil villain in a superhero movie or something.
My supervillain name is Depression Carl.
There you go. And we don't want you to turn into Tropical Storm Carl. It's kind of like a Hulk thing, I guess. I don't know. But yeah, so I don't know that it's official, but they are talking a lot more about depressions than ever before. And again, half of them don't make it out. So we'll see. Here's some ancient radar. And I suppose, again, this is why weather geeks really come into their time, because we can see real live radar. I remember when the Weather Channel was just a computery, blippy screen. It was still a channel, but there weren't humans on it. It was just feeds. And that wasn't that long ago either. This is 95. And I know 95 was a long time ago, but it was only like 10 years before you guys were born, so that's not that long ago. And stuff was this primitive. These two things they're pointing out as hurricanes actually look way less like a hurricane than the tropical storm in the upper left-hand corner does. If you follow the weather and you worry about storms and stuff, you may hear the meteorologists talk about with tornadoes, we worry about the comma shape, right? Always worried about the comma shape. Well, that's definitely an indicator. With tornadoes, they're worried the comma shape means rotation. Well, that's exactly what we want to see here. We want to look for that rotation. These guys are rotating, these hurricanes. It's just, again, the resolution wasn't good enough, and they just look like blobs. The depression's even more blobby. Again, Tropical Storm Jerry. Doesn't sound too threatening, but some of the names are scarier than others.
Are they called depressions because that's where the clouds
Well, the depression is the low, I think. It's where they we're going to get to a slide,
yeah,
but it's essentially when the low pressure is visible, the low pressure center, the axle, so to speak.
So like an actual depression?
No, not like a dip. Like again, picture a wagon wheel. In the center of the wagon wheel, where the hub is and the spoke would be, that's literally a hole. I mean, it is sort of a depression, but they're talking about pressure, numerical depression, not a physical depression, so to speak. It's a dip in numbers. So, and like I said, we got a slide, so hopefully this will clear it up a little bit. So a group of thunderstorms have come together under the right atmospheric conditions for a long enough time. They may organize into a tropical depression. Winds at the center constantly 23 to 39 miles per hour. So 20 to 40 miles per hour. We've got an organized storm system. And again, that's, that comes blowing through here where you're going to know it. You're going to know it. On, most coastal areas, let alone islands, again, that's not an everyday occurrence. That's fairly strong wind. And again, it's organized with, group of thunderstorms that are ready to begin with, let alone the strong winds. So it's designated when the first appearance of the low pressure and organized circulation. All right. So that's what we're looking at there, which is what I actually said. I'm glad I matched my slides. So these are a lot of sentences. I see some of you frantically pencil whipping there. A lot of this is narrative. Don't, get the important things. Get the numbers. Again, remember, you're going to have access to these slides.
Could you go back to the...
Then that's my point exactly. So no, I don't generally go back. Because we don't want you guys scribbling down every single thing that's up here. But grab the important stuff. When I'm talking and what's up there. But yeah, and again, that's why I post these for you guys. And also, your hand's going to cramp up. You write that much. So again, the important part, it's a depression when we have the low pressure center and the circulation begins. And the circulation, it's kind of circular, no pun intended, but the circulation is happening because there is that pressure differential. And again, blurry picture of a cloud. But that's a tropical depression. You see the commas sort of there, starting. It's more like an apostrophe right now. Next step, tropical storm. The primary difference here is wind speed. 40 to 73, all right? I know it says 39, but 40 to 73. I'll try to make it a little easier on you guys. And again, my multiple choice questions are not going to be 39 to 73, 38 to 72. I'm not that big of a jerk. So, more about magnitude. What? Now, I don't know. I'm sure you guys don't speed, but I'm sure also a handful of you have had your hand out the window at 70 miles an hour. All right? It's not the same thing. It's not the same thing. There used to be a few things around. What's the Science Museum at the mall? The Science Activity Center there. Wonderworks. They used to have a hurricane simulator in there.
Isn't that like a tube where you step in?
A tube, phone booth kind of looking thing. Yeah, a mixture of, and again, depends on the company. That's a lot different experience than having your hand out the window. Not just because it's full body, but I think just because it's coming at you in a lot of different directions. If you ever see one in a mall somewhere, it's worth the $5. Put it in. Kind of fun. Blow your glasses right off your face, for sure. 73 miles per hour is a lot of wind. Again, here, just ecology, environment not designed to take that.
It was very windy yesterday around 3, 4-ish.
Okay.
I know that's definitely not anywhere close to that.
Yeah. I don't remember. I'm sure. What was I doing? I was home, but yeah, the wind. Because you see winds here when the air patterns are changing. You see, generally, you'll see a temperature difference with the wind after and before. So tropical storm. At this point, the storm becomes more organized. It definitely starts to become circular. It looks like a hurricane. And again, as we told you earlier, at storm, we give it a name. Primarily, I'm guessing, not just because it's likely to turn into a hurricane, because we already said that's not always true. But tropical storms are bad enough that they're going to talk about them a lot. And I think they just found, by convention, it was easier to give it a name. than anything else. I remember one year we finished the alphabet. They go alphabetical, alternate male, female. One year we finished the alphabet and they went into Greek letters, I think. Something like that, I forget. But they had to start the alphabet over one year. It's crazy. All right. As the surface pressure continues to drop, and we don't have values for this low pressure center. Don't worry about that. As the low continues to form and gets slower, the wind speeds are going to increase. Again, remember, we just brought up here that wind speed is a function of different air masses, different temperatures. Okay, and so the hotter it is on the outside of that hurricane, the cooler it is on the center. All these things are going to come in and affect how fast those winds are moving in and flying around. Once we get a very pronounced rotation and wind speeds above 74 miles per hour, well, they get to be called a hurricane. This one's pretty nice detail. Again, you can see the eye wall. You can see it's the donut in the center. All right. You can see the eye and beautiful, beautiful rain bands on here. So I've used these words already. Each one of them is going to get their own slide in a minute. So if you don't see or get everything in this one, you will get a chance in a moment. So again, the center of the storm is the eye. The area just around that is the eye wall. That's that donut in the center of all these pictures. It's the eye wall. All right, and it's the most intense part. It's the thickest, so one might assume. There's a handful of different words for rain bands. I've just used rain bands. There are other ways that people will refer to them, though. It's the little streamers coming off of the hurricane. I'm going to change it, but like I said, you'll see them again. So the eye is the most recognizable feature. Between 20 and 50 kilometers in diameter. I didn't even bother translating that because that's not something I want you to worry about. But the eye is the calm in the center of the storm. Let me see if I have another slide on eye. If not, I'll stay on this one. Yeah, it is. Wait a minute. Did I switch slides or did I not? Yeah, I did. So it is the focus. That's that axle we talked about before. It's that hub. It's where everything is rotating around it. And again, God forbid you guys should be in a hurricane, but the old cliche is, of course, when that calm comes over you, when the eye passes through, you're going to want to run out and look for your kitty or your whoever escaped. Make sure you want to check the damage on your property, so on and so forth. And I'm not going to tell you don't do that because I do the same stupid thing, especially if a cat or somebody was out there. But be quick, be brief, because you don't know how big the eye is, okay? And again, yeah, there were some numbers listed in your textbook, but you don't know. And the reason I say that is because what do we say comes right after the eye? The eye wall, right? The worst part of the storm. So you're going to leave the worst part of the storm. It's going to be a blue, sunny sky, stop raining, everything, no wind, nothing. And then you immediately go back into the worst part of the storm. You do not want to be driving around looking for your damn cat. Okay? So technically I have to say that, but again, I'd be driving around looking for my damn cat. So yeah, don't go buy more beer during the eye, whatever, all those things. Ideally the stores would be closed anyhow, but you know what I mean. Next is the eye wall. Not much difference in this picture, but again, on any of the The newer images, it's usually quite visible. And this is the worst part of the storm, most strongest winds, worst rainfall, etc., etc. Eyewall bad.
Looks like waves.
Yeah. There's not a whole lot of mad scientists left in the world. Those that are around seem to have congregated to meteorology. You've all seen, I don't watch them, but I know on like Discovery Channel and whatnot, there's all those storm chaser crazies out there and whatever.
I remember seeing either a show or a video of someone, like, they had a really, like, heavy decked out, like, truck that they would try to drive into the center of, like, a tornado or something.
Oh yeah, yeah, that's them. And again, I don't recommend that. I love looking at storms from far away. But this one was somebody in an airplane. This is older than drones.
Yeah, I can see this.
So nowadays, we would hopefully send a drone in to do work like this. But this is somebody who dropped down either into the eye. I got one more picture. This one, it looks like it's above the eye wall. Yeah, this one they dropped down into the eye.
Whoa.
So I don't know a whole lot about flying, but I do know that air pressure is important.
Yeah, I was
So
going to
this
say,
was- Yeah. So this was probably a pretty crazy thing to do. But again, we've got some research out of it, with, in the name of science, so to speak. But nowadays we could send droids to do this, which is nice. But I'm sure there's still people who want to do it. So some amazing cloud structure there. And again. So I'm not sure why I went back to this picture here, probably just to remind you where we are. Let's talk about the eye. You can see the eye wall there. And then everything else spiraling out with the huge structures we see a hurricane. That's all going to be these rain bands. And there's going to be a bunch of slides, and you guys are going to be frantically trying to write stuff down. Again, please don't. The gist of it is, and you could probably logic this out yourselves, the closer you are to that eye, the more intense, the more continuous, the more everything the storm is. As you get to the outskirts, it becomes less and less and less. So just kind of like imagine a storm approaching, okay? The outer rain bands are going to hit you first. It's going to start to rain, and it'll stop and get windy or whatever. Then it's just going to get more and more intense as it goes through. Less breaks. You can see some blue in there through the rain bands. All right. So that's the gist. Until you get into that middle part there, before the donut, it's just solid. Yes, sir.
If a hurricane goes like inland and then goes back out to sea, how is it gonna like reform, or is it just gonna get stronger as it's like?
Yeah, it's like what?
Does it rebuild that shape, or does it like stay the shape it?
We're gonna get there.
All right.
We're gonna get there, and that's exactly what actually we could see with Adelia. You'll see it in the very end slides there. So, good question, but hold that thought. So the rain bands. Again, we've talked about these. These are just basically all that weather that they're pulling into it. And that's another thing where we mentioned how I mentioned how we get weather up here from these storms. I haven't seen any studies, for lack of a better word, about this. I haven't seen it in print or heard a meteorologist talk about it. But it seems like when these things do manage to make it this far inland, that it starts to pull stuff down towards it. All right. When we see these pictures, it's easy enough to believe that it's sucking in the stuff that's around it. That's how it's feeding itself. But I think almost as a system, for us, it starts to pull stuff down from Canada a little bit. And it's just an observation I've made over the years. I don't know that there's anything to it or not. All right, we talked about this. Less gaps as you get further in. And I just actually told you this too. This is that cross section. If it was to go over you, right? You're going to have little bits of rain and wind here, and then a break, and then a little bit more rain, and then maybe another break, but eventually no breaks. More rain, more wind. Then you get to that absolute worst part, and then nothing. And then right back to the worst part again, and then it fades out from there. Again, with the winds, the same idea. The wind speed reaches its maximum in the eye wall. And then within the eye, the winds become very, very light. Non-existent, even, as I said. And then it kicks right back up again on the other side. So you move from high to low pressure, and then it just stops. I think the reason it stops has a lot to do with the rotation itself. Physics is far from my forte, but I do think that has a lot to do with it. It contains the center. It sort of allows it to just be there. And I think that, again, I don't know an average low pressure either. You don't need any more numbers right now, but I'm sure there's a typical number. So sort of getting to your question, here's the hugest thing. Out to sea, these things can last, I don't want to say indefinitely, but a long time. Why? Because you've got the water there. You're feeding these things. You've got better chance for humidity, et cetera, et cetera, et cetera. But as soon as they hit land, all right, the land is way cooler temperature-wise, and there's no humidity, moisture, at least significantly less. All right, I'm not going to say that Florida isn't humid. That's not what we mean. But compared to being over the ocean, all right, there's nothing left to feed it anymore. So 9 times out of 10, once we come ashore, these things fall apart rather rapidly. Not always, but they tend to fall apart. They lose intensity at any rate. All right, so we're going to change gears a little bit and talk about categorizing or ranking. That's what scientists love to do, right? So you got the Saffir-Simpson scale. You've heard of the Richter scale for earthquakes. This is similar. It just gives us a uniform idea of intensity, of badness. So the Saffir-Simpson scale goes from 1 to 5, 5 being the most devastating. All right. And all these people that were fretting about climate change and oh my God, we're going to need to make a 6. And no, you don't need to make a 6 because 5 is total devastation. There's nothing beyond total devastation. So there's no reason to change it. Again, I am definitely a believer, whatever you want to say, in the science and so on and so forth. But I'm also no fan of the scare tactics either. So it's, 5 is good enough. I'm not going to have you guys memorize these numbers. I do want you to remember what's considered a severe when it's bad, which is level 3. We'll get there in a minute. And I do want you to remember what speed it starts at, which is 74. All right? But otherwise, please don't use your brain power trying to remember that a Cat 2 runs from this to this. You got other things to cram in your head. All right? All right, so category 1, 74 to 95 miles per hour. The Floridians were saying, it hit Manhattan. It's just a category 1. Yeah, could you imagine 90-mile-an-hour winds blowing through Manhattan? Yeah, that was bad for them. Everything is relevant. Everything is relative. All right?
Just like how the hurricane that hit, was it California or?
They did have
West Coast.
They did have a West Coaster and I didn't get to use that for you guys, but for summer we had it. Yeah, that was super rare, and it did hit it as a Cat 1, I think.
And it was super bad for them because they
Not
barely
used
ever have to
to it,
deal
yeah.
with that.
They're at sea level too, which same thing with Manhattan. People don't think about that. If you've ever been to one of the edges of Manhattan, it is at sea level. Storm surge. We got to talk about storm surge for a moment. 4 to 5 feet. Some damage to trees, shrubbery, and unanchored mobile homes. Storm surge. So most of you know what tide is. If you've been lucky enough to get to a beach, you know that tide level changes throughout the day. There's high tide, there's low tide, there's normal, just in between. That's not the same thing as storm surge. All right? What storm surge is not a horizontal measure so much like tide is. It's a vertical measure. And then you add the horizontal. Here's what I mean. So you're standing there, picture yourself at your happy place, whatever ocean that might be, and your ankles are wet. Now move that water level, where's 4 to 5 feet? Your shoulders. Move that water level up to your shoulders. Turn around and look inland. Everywhere that is below your shoulders will be underwater. That's what storm surge is. It's a difference. It's not tide. So 4 to 5 feet above the ground level, and as far as you can go. Yeah, hopefully there's a dune in the way. That's kind of why they're there. And then you get to the condos, hotels, the town, whatever. T-shirt shops, mini golf. So right off the bat, we're looking at a huge surge. They were just talking the other day, and I don't know again how it played out, but they were worried that high tide, full moon affects tides, right? So they were worried that the extra high tide might affect this. That's usually inches. So again, I don't know that it played out, but that's one of the dangers of knowing a little bit about stuff is you say, oh my gosh, if this and this come together, then that could make.
Yeah, I feel like the moon at that point is going to have less effect on the water, like the gravity of it than the 95-mile-an-hour winds right above it.
Yeah, there's for sure. All right, so 74 to 95. Hopefully you've not felt 95-mile-per-hour winds on your hand. But if you have, then you know that's pretty dang strong. Cat 2 jumps up to 110. Storm surge up to 8 feet. So now way over your head, inland. Still, if the dunes are in place, should protect a lot of the town, but you got blowing over and rains, and then the dunes can also help keep the water on the other side of the dune as well when it rains in there. But this is why sand dunes are important. Cat 3, up to 130 miles per hour for wind. 9 to 12 feet of storm surge. Trees are down. Buildings are starting to get ripped up. And not to throw another controversial subject in here, but evolution. This is evolution of plants. Nobody really cares about that. It's only when you talk about people that they get antsy. But do you ever notice the kind of trees they tend to have down south? Big, tall, skinny palm trees without a lot of branches and rather bendy.
Less surface area for the wind to.
So you don't see a whole lot of big oaks and maples and all that down there. They'd snap right in half, or if they did try to get a hold millions of years ago, they found it unhospitable. All right, now that's not an argument as to why we don't have palm trees up here. They just don't like the weather. But it does show selectivity. I was watching, not that long ago, sadly. I put 2 and 2 together. I was watching some video footage, and these trees are just going all the way down, practically bending down to the ground. And then the gust goes away, and it just springs right back up, like Big Red Wiggly guy at the car shops, right out there waving all around in the wind. Leaves were still there. So those trees are somewhere where they can live, even through those storms. So again, when that stuff starts moving up here, we're going to see a lot different damage. This is one of the problems. Actually, I had a point to this conversation. That's one of the problems with this third bullet in any one of these things. Again, it's relative to where you are. They build for stuff in hurricane-prone areas, just like in earthquake-prone areas. Engineers, they build buildings, structures that have that in mind. They know it's likely to earthquake there, so they build stuff with that in mind. Same thing is true of hurricanes for the most part. Again, where they can afford to do so, and so on and so forth. So as we see weather patterns change, we're going to see these storms migrating northward or whatever ends up happening. I think we'll see different damage, worse damage, unfortunately, than we're supposed to by these category ratings. So, anywho, Cat 3, 130. 155 and 18 feet. Now you're over your dunes, for sure. All right. Cat 4 up to 155, 18 feet. Cat 5 over 155, over 18 feet. Again, this is why there is no need for a 6. Just everything is ruined. So, yes, again, some amazingly engineered homes have been built to withstand this, but, you know, nobody could afford them. If you've been to the beach and you wondered why there's houses on posts a lot of times, okay, this is why, to get you through some of the normal stuff. Again, it's not going to help a Cat 5, or even a 4 probably, but your usual flooding, your inundation, you know, they put their house up on, they don't have basements, they're on, and you can park your cars under there, which is nice too. But that's why you see these houses on those posts, pillars.
I feel like the houses that are really close to the sea in hurricane areas are like probably going to be very cheap comparatively.
Absolutely not, because they're on the beach.
Yeah, that makes it worth it.
Apparently it does, because you go look at housing. Go look at housing. When you're bored one day, it's the exact opposite. The further into town you are, the cheaper it goes. They don't worry about hurricanes. To that level, at any rate. Because you have the other 363 days a year when you don't worry about it. Cat 3 is where we start to worry about these things. And again, we joke about Florida. We shouldn't. But, you know, even with this 4 that was coming in, people weren't leaving. They're getting used to it, so to speak. But 3 is what, you know, scientists, mayors, presidents, whatever, say, hey, this is intense. This is something you should worry about. This is something you should get the hell out for, especially if you're a tourist and you're not used to this stuff. Like I said, I'm really surprised they evacuated the Army base. It must have been a 4 or something. It must have been a Highland, or whatever base. I shouldn't say you're in the Army. I don't know what you're in, but military base. We don't get a whole lot of 5s. Thank goodness. Florida Keys in 35, Camille in 69, Opal in 95, and Fran in 96 weren't verified as 5. I'm pretty sure they were strong 4s, the way I'm wording that here. And again, Katrina.
Katrina wasn't a Category 5?
Was not.
Oh, God.
It was in the water. By the time it hit, it dropped. But again, is there... I forget my own numbers here. Is there a hell of a lot of difference between 150 miles per hour and 155? No. Okay. So that's why I'm saying, you know, oh, it wasn't a 5. Yeah, but... So... These categories are just for the scientists, okay? For the people living there, you know, bad is bad. So we've been spending all this time talking about hurricanes. You might have been thinking, well, what about those other words I've heard? Are they the same thing? Yeah, they are the same thing. Cyclones, typhoons, different cultures have different names for them. Largely ocean-based, okay? In the Pacific, up to not quite the equator, but from the equator northward-ish, they call them typhoons. And they do not tend to hit the west coast of North America. They tend to hit the east coast of Asia, okay, and all those islands there. In the southern area there, they call them cyclones. And again, they don't tend to hit the west coast of South America very often. The Atlantic's got a cold stream that runs along North and South America there, and that's why this was so crazy. It moves in and out. It's not always there. There's certainly warm water. That's not what I'm saying. But there's enough of it over there that it tends to just dissuade this from happening. Here's a map to give you an idea.
They all start around the equator.
Well, that's where your warmest water is. That's where your most humidity is, and yeah, exactly. So we started naming them in '53. As a depression turns into a storm, it's given the next available name on the list. They alternate male, female, and I think even like year to year, last year we started with male. Okay, this year we'll start with female. I think it works that way. Somebody gets to make that list. Wouldn't that be a cool job? Maybe. I have a feeling it's just like a one-day thing, but yeah, that's somebody's job to make the list. And it's been getting very multicultural lately, if you haven't noticed, which is kind of neat. So they only can run through Henry and Tom and Jerry so many times. So they're starting to mix other names in now, which is nice. So this is just my citation here because this stuff isn't in your textbook. It's in the Earth Science folks textbook a little bit, even they don't get a whole chapter to hurricanes. But so I stole this from University of Illinois. Again, who would think, right? They'd worry about hurricanes. But true story. At the time, I didn't know there were two schools in Buffalo there, University of Buffalo and Buffalo State. Those are the two. So I don't know which one it was, but I met a guy at a conference who worked at, geology guy worked at Buffalo. I'm like, so what do you think? There's volcanoes. I'm like, oh, you guys have to do a lot of field trips, huh? He didn't laugh. I thought it was funny. But, so yeah, you could study volcanoes living in Buffalo. You could study hurricanes living in Illinois. So Katrina, 2005. I thought it was a lot earlier than that. What's the one in the 90s I was thinking of then? So it peaked at a 5. It was a 5 briefly, but it hit the coast as a 4. And again, you want to look at the wind speeds on that. It doesn't mean that was a huge relief to those people. Okay, it quite likely didn't mean a whole lot. So when we look at Adelia, is that the one that's out right now? That's a teenager compared to this thing.
That's okay. Katrina?
That's Katrina.
And that's it over New Orleans?
Yeah, that right in the center there is still a little blue, but I see green just above it. And you're going to see in a couple minutes where the rain bands go up to. It's bigger than Florida.
So, you said that New Orleans was shaped like a bowl, and that's why, it took a lot. One of the reasons why it took a lot of damage. Has that same area, been taking a lot of damage every time a hurricane goes through?
Yeah. It's being erased. We'll talk about it during groundwater, probably the groundwater lecture. But for a handful of reasons, mainly because we use the Mississippi for transportation so much, we keep it dredged out. We keep it clean and deep. All that sediment for years has been going right down to the Gulf Coast and kind of keeping up the land with the waves. The waves wear stuff away. So the waves have been erasing Louisiana, but the sediment coming down has been keeping Louisiana there. So ever since the Army Corps of Engineers started dredging the Mississippi, there's been a net deficit of sediment, which has been degrading them. And then also the subsidence, which means sinking, it's not getting any higher at any rate. So it's still fairly bowl-shaped. But so this here goes back to showing you guys what I was saying about how I think that these hurricanes pull in. Doesn't it look like it's pulling that's weather down from up north by the Great Lakes there?
Yeah, like that.
Yeah. So I think that's a lot of when we see weather here. It's not just the rain bands, but stuff that's been pulled down from above us. So I don't have the timestamps on these things, but this is obviously further inland, and this was another problem because we just told you that once they hit inland, they start to fall apart. Well, if the damn thing is so huge, it's going to take a lot longer for it to fall apart. This stayed together a long time.
Those rain bands are going up to New York.
Yes, they are. You can see Lake Erie right there, and that ends at Buffalo, as you guys probably know. And then Lake Ontario is next. But yeah, that's New York State in the picture there. Jump ahead. Irene. You guys were alive, probably not paying attention too much. Irene came in 2011, hit right smack dab in the middle of the Atlantic coast, slathering everywhere from Carolinas to New England. This is the one that took out a lot of stuff in Jersey. Again, if your family goes to Jersey Shores, you might remember there was Time Life magazine cover was the Ferris wheel from, it wasn't Cape May, one of those famous boardwalk towns. It just looks like it's out in the middle of the ocean. There was so much water there. It was a big deal. There's Irene, again, no slouch. This is Cuba, Florida. So again, we're on the ocean side here, not the Gulf side.
Looks small in Florida, and definitely doesn't look too small there.
No. The states are in there. So here's your Cape Cod out there. My geography's pretty bad, but we're going to call that Long Island. Yeah. But it's hit. Where's the eye? Let's find the eye. The eye's probably, I'm using the mouse for the folks at home again. Right there's your eye. So again, the worst of it is there, but we're not used to getting this crap. Not used to getting that at all. That's Pennsylvania. You're not looking at New York. That's Pennsylvania there, right here. New York is here. Still a lot of rain for us. There's some radar. That hit as a Category 2. So the reason I point that out is that category doesn't necessarily have anything to do with size, diameter. Category is all about wind speed. So you could have a giant Cat 2 and again have worse effects than a small Cat 4, big picture kind of thing. Hit Manhattan is a Category 1, quickly dropped to a tropical storm, but again, they're not used to tropical storms. Subways flooded. It was crazy.
And trains and submarines.
Yeah. And here's my wonderful iPhone pics. That pin is us. So you'll see these things move over the pin there. So we get closer. Where'd the pin go? Yeah.
Down south near Canada.
So we are right there. So that was not even grazing us. We got drenched. I lived by Sequoia Creek for a while. For those of you familiar with Sequoia Creek, it doesn't usually look like this. Usually you could walk in it ankle deep. It really doesn't look like that. We got a lot of rain. I have to tell Professor Dizzy I've got her husband sign one of my slides. That's funny. So yeah, we had the boy out in this. We actually had the baby out in it too, but she had one of those plastic bubbles go around her stroller. But it's family earth science. What do you want? We got to go out in the storms. One house from us down, they evacuated, and I yelled out. I was just, a young dad, so to speak. I said, "Hey, Rex, you leaving?" "Hell no." "Okay, I guess we'll stay too." And again, it wasn't anything. We didn't take water in or anything. It wasn't until the floods of 2020. When did everything, all hell break loose in Utica, South Utica? I think it was 2020, 2019 maybe. Halloween night, you guys remember that? Yeah, that's when we finally got water. Yes, sir.
I remember a few years ago, I think 2016-ish, going down to Utica, there was a section, it was raining hard, and there was a section of the road that was just like covered in water,
Oh, yeah.
shooting up and then covering like just one like 20-foot section of the road or something.
It's happened a few times down the arterial, and they did some work to fix it. The arterial basically turned into a water slide down by where big, tall, pretty church down there, just past Utica Cutlery and all that. Right down in there, it was horrible. But that describes a lot. Like I said, Sequoia Creek, where you cross from New Hartford to South Utica, right there, that was running right over that Halloween night. So that's happened a couple times. They're working on fixing it. All right, so as I said, I did put something together real quick for the new one. And where to find it is another. So this is Adelia. Probably horribly mispronouncing it. This one hit fairly south. The Gulf up here, New Orleans and Alabama and whatnot, was pretty spared. The predictions are crazy, and they're just running a bunch of math models based on winds and temperatures and all kinds of things. So these predictors that you see early on are a little sketchy. I wish I had taken one the night before when it was a little further off, or earlier on Tuesday, I should say. But by this point, it was fairly clear where it was going to hit. And its trajectory, again, the eye is, I don't have my good glasses on today. The eye's right there-ish. Oops, wrong way. So next time I checked, actually, no, this is still the same night, but I let the radar projector run through. So it was still 11:30 Tuesday night, but I let the projector run through to 5:30 the next morning. And it had moved mostly ashore and a little north, which was surprised me a little bit. I thought it was just going to cut right across Florida. Actual Wednesday morning, it moved again. All right. So again, it's really hard to predict where these things are going. It's definitely becoming less organized, as you can see. Somewhere in between the words Tallahassee and Jacksonville would be the old eye. Tuesday afternoon, just some serious storms for Georgia and South Carolina. Last night, moved into North Carolina. That's pretty, no? I don't know if they use a filter. Can't, say for what the folks at OBX did. But that's pretty damn amazing. And that's one of the things. You're watching these folks on the Weather Channel or the local news. And even me, a couple times today, I said, oh, isn't that beautiful? Isn't that pretty? Nature is awesome. Nature's amazing. And it makes some amazing things. And sometimes when you spend your life, studying these things, meteorologist, for example, you can't help be blown away by a really awesome example of something you've spent your life studying. So sometimes when they interview these people, they almost seem sort of removed from humanity, for lack of a better word. Yes, it just killed 300 people and leveled 1,500 people's houses, but they're sitting there talking about how pretty it is and it's amazing, and forgive them. Okay, it's kind of like when an accountant gets a really, really messed up job. All right, yeah, it so sucks for those people, but the accountant's just like smiling. Right, you got to imagine it, at any rate. It's kind of like that, because that's just I would have loved to have been there to see that. As miserable as it would have been to get rained on and blown around and all that other stuff, but and just a little levity. So your various categories, the miles per hours. Ooh, is that accurate? 74.95. I'm not sure Cat 5 is right, but
It's
like
155 or
that's
higher.
what I thought. That's what I thought. I like Cat 3 though. That's the most messed up kitty there. All right, yeah, you can stop that. All right, so I'd say questions, but I don't know that I can answer a whole heck of a lot of them. But any questions, thoughts, concerns, other than meows, about this? Yeah.
What is the biggest hurricane that ever hit anywhere?
Well, we listed two of them back there. I don't remember their names. One was in the Keys in 55 or so. And that's probably when we started the naming thing, too. But we only have two Cat 5s on record, and I don't know, what we have for their wind speeds and whatnot, but they were fairly devastating. And I don't know about other parts of the world as well. Typhoons and whatnot that have hit over in Asia or some of the islands in the Pacific. I don't have that kind of data, and again, all of that is a function of how good your equipment is for measuring too. So you got to take a lot of that with a grain of salt. And again, we shouldn't be quibbling over 155 versus 157 for miles per hour because they're both. It's not time to go. They're both fairly horrible.
The difference is so small, it doesn't matter.
Good question. What else? Okay. Well, keep your ear out. I don't know. I seem to be missing some slides in this. I don't know why. Hurricane season runs through November. Okay. It doesn't start until August. Again, typically because we need time to get the temperatures up. I don't know. I'll have to look for that slide. I don't know where it went. But it does run through November. Okay. And we've even had a few years back, we had one that went into December, very recently. And it hit Michigan, of all things, which was weird. So yeah, things are changing. These folks aren't making this stuff up. Okay. I am by no means an expert, but I do try to be a bit of a realist. And I want to get out of the weather up here, for example, when I retire. My wife wants absolutely nothing to do with the coast because sea level rise, this, that. I'm like, honey, that's going to take decades. We'll be long dead before, maybe I'm underreacting. But things are changing, okay? How exactly they're going to change, we're still learning. And that's one of the other things that we'll talk about with Nature of Science when we actually start lecture proper on Tuesday. But it's a gathering data process, and COVID pointed that out horrendously. And then the scientists, they don't know, they keep changing their minds, they don't know what they're talking. Well, no, we keep getting new data. And for example, when we were in college, my generation, they were absolutely positive that we were just going to get a shift. Florida weather would move up to Carolinas. Carolinas weather would move up to PA. PA weather would move up to Vermont. Everything was just going to shift. And that isn't what ended up happening. Stuff did get warmer, but it changed in ways they couldn't imagine. Like, for example, everyone knows that cold water sinks, all right? Cold water is more dense than warm water. But nobody calculated the effects of these ice things melting and that water sinking and throwing up unoxygenated water from the deep, which did something else, which did something else. And like, oh, well, yeah, you knew that's true, but who thought to throw it into the equation kind of thing? So we're seeing weather patterns shift entirely, not just temperatures shifting. So God only knows, and possibly not even he or she knows, but what's going to be. But it is changing. All right, things are getting different. Yes, sir, you had a question.
Since the water in the ocean, it cools down slower than the land cools down, right?
Any large body of water does cool down slower, yeah.
So would that affect the severity of a hurricane if there's like a huge difference in temperatures, or would it just affect?
Oh, when it hits
duration?
land, you mean?
Yeah, or like its formation or anything.
They might die out quicker. I think it's more the humidity that kills them, the lack thereof. But yeah, that's something. There's a graduate school project for you there. Find out if hurricanes in November fade out quicker than hurricanes in July. Or August, I should say. We don't have hurricane season in July yet. Good question. All right. I'm going to hit stop on the recorder, and I'm going to take attendance, and then you guys are free to roam about the planet.